Hi there, I'm Jet.
And I'm Adarsh.
We're students from Google Summer of Code, and we're happy to present Facet AI, where we're trying to democratize small language model fine tuning so you can bring out the best facet of Gemma. And our platform allows you to manage fine tuning jobs from data preprocessing, formatting, all the way to export and deploying your model without writing a single line of code. And today we're going to go through a simple use case while we support a lot more complicated multimodal and different trainer types, and you can refer to those on our documentation. So after you've logged into our platform with your accounts, you should go to the profile page to set a few access tokens. And these allow you to access gated dataset, model, upload your model to Hugging Face, and so on and so forth. And you can refer to our documentation for how to access them. And now let's start with datasets.
Cool. We have the multimodal OpenR1 dataset already processed. It's an image based reasoning dataset. You can see all the information right from the home page. Now, here we can see some processed examples. It has system message, user message, and a solution. Let's see how we can create a dataset ourselves. We can either upload a custom dataset or one from Hugging Face. I found this amazing dataset, latex OCR. So I'll just paste it here. And after selecting few configs, I should see the preview. As you can see, this is an image-based dataset. In the image part, it includes mathematical formulas, and the text is basically latex from those images. I can finalize the dataset. To enter the name, I'll say OCR text. I can select some processing modes. You can read more about these in our documentation. In the field mapping, I'll enter a simple template called URL helpful assistant for OCR from image to text. In the user messages, it's an image, so I'll select image, and in the assistant message, I'll select text. I can do different kind of splittings. For now, I'll select the train split for manual splitting and few thousand rows for easier processing. I can also select data augmentation, but it's fine for now. I can start the processing. Now that we have our dataset processed, you can look at some samples. It looks good. Now it's time to create a fine-tuned model.
So to create a training job, you can first select a model. And we support Unsloth and Hugging Face. Here are different model configuration, different type of Gemma. And you can then support select a dataset. We'll use the one that we just created. And here we will enter some detail about the job, about this type of train job we want to create. We support full fine tuning and using adapters. We'll use adapter here. We also support other trainer types, such as different flavors of reinforcement learning, but those are left for other tutorials. We'll use one epoch. There are a lot of other configuration you can do, but for most beginner use cases, using a default we provide is good enough. Now we will submit the training job. And while this one is being queued and processed, let's look at one that we have created before. So there are a lot of job details shown here, but we'll go look at the logs on weight and biases to see how the training went. We will soon also introduce native logging in our platform directly for those who this does not have a weight and bias account. But this is also a way to see how your training went. And if you're using RL, you can see all the changes with rewards, scale, divergence, and all those metrics all logged here automatically. So let's go back to our training page and let's see how we can evaluate a model after it's being trained. So let's evaluate a model we've trained before deploying and exporting it. Let's compare a model that's not trained with the model that we have trained. So for evaluation, we can either use a metric-based approach. This is great for benchmarking or more complex tasks like machine translation. You might want to compute some scores like Blue Score is all available here. But for this task, it's relatively simple. Let's just run a few samples and see how the two model does. Let's load a sample from our dataset, from a test set, and let's run it through the model that we have not trained first. So this model is trained to predict a chess move given a bunch of past moves and a given score. And here you can see that the model is not exactly outputting something that's really helpful, for example, in response to. And let's look at the model that we have trained on the same samples to see if it's actually doing better. And you see a clear difference here. This model outputs in the structured format that we wanted for our task, and everything looks exactly right, like what we expect in our dataset. So after evaluation, let's move ahead to exports.
Cool. So now we have our model fine-tuned and evaluated. Now let's export the model. We can go to chess model 2 and we can see all the information. No exports are available as of now. For this tutorial, let's do gguf with direct download. With one click, I can start the export. Now the export job is created and we'll have to wait some time for it to finish. So the export was successful. You can see they have a download button. I have downloaded the model already and I have it in my Olama folder. You can see we have a model.gguf and a model file. The model file already includes the file and the system prompt. Now let's create the model and run it. We'll need an input. So I'll simply go to our dataset and copy the input from there. As you can see, our model is properly telling us which move was missing.
And that's a wrap for today's overview of Facet AI. And I hope you enjoyed this demo. If you want to watch like a tutorial on how to train models end to end, or like more specific configurations for great customization, check out our documentation. Everything is documented here, and also our GitHub. And make sure to follow us. And we hope you enjoy the platform.
We're really excited to see what you craft with Facet AI. Thanks for watching. Bye bye.